Now let us start the second list problems. First one, integral 2x plus 8 whole to the power of 8 dx. Now this is in the form of integral ax plus b whole power n dx. We know the formula for this. It is ax plus b whole to the power of n plus 1 by n plus 1 into e. When we substitute the formula here, we get 2x plus 8 whole to the power of 8 plus 1 by 8 plus 1 into, in the place of a, we have 2. So, we write 2 in the denominator. It is equals to 2x plus 8 whole to the power of 9 by 2 into 9, 18 plus c. This is the final answer. Next, second one. Integral 3x minus 2 whole to the power of 1 by 2. Now, for this we have integral ax plus b whole to the power of 1 by 2 dx. This is nothing but integral square root of ax plus b into dx. 2 by 3, formula is 2 by 3 ax plus b whole to the power of 3 by 2 plus c. When we apply the formula here, we get 2 by 3 into 3x minus 2 whole to the power of 3 by 2, and in the denominator, what is the coefficient of x? It is 3. When we simplify it, we can write this as 2 by 3 is 9 into 3x minus 2 whole to the power of 3 by 2 plus c. Next, third one, integral e power 2x dx. Integral e power 2x dx. This is in the form of integral e power ax dx. We know the formula for this. This equals to e power ax by a plus c. When we substitute the formula, we have e power 2x by 2 plus 2. Next, fourth one, integral 1 by 7x plus 3 dx. This is in the form of integral 1 by ax plus b dx. It is equals to log of ax plus b whole divided by a plus c. When we substitute the formula here, we get log of 7x plus 3 whole divided by, now what's the coefficient of x? It is 7. So write it in the denominator plus c. This is the final answer. Next question, fifth one. Integral sine 7x dx. This is in the form of integral sine ax dx. It is equals to minus cos ax by a plus c. When we substitute the formula here, we get integral sine 7x minus cos 7x by, what is the coefficient of x? 7 plus c. Next, sixth one, integral 1 by square root of 1 plus 5x dx. This is in the form of integral 1 by square root of ax plus b dx. It is equals to 2 root ax plus b by a plus c. When we substitute the formula here, we get 2 root of 1 plus 5x, and in the denominator, what is the coefficient of x? It is 5. Write it in the denominator plus c. Next, seventh one, integral 1 by 3 minus 7x dx. This is similar to integral 1 by ax plus b dx. It is equals to log of ax plus b by a plus c. When we substitute it here, we get log of 3 minus 7x. In the denominator, what is the coefficient of x? It is minus 7. So, we write minus 7 in the denominator plus c. Next, eighth one. Integral 1 by root of 3 plus 5x dx. This is similar to this formula. Integral 1 by square root of ax plus b. We know the formula. 2 root of ax plus b by a plus c. When we substitute the formula here, we get 2 root of 3 plus 5x, and in the denominator, what is the coefficient of x? It is 5. Write it in the denominator, plus c. Next one, ninth question. Integral a power 5 minus 6x dx. This is in the form of integral a to the power of bx plus c dx. We know the formula for it. It is a power bx plus c by log a into, what is the coefficient of x? It is b. When we substitute in the formula here, we get a to the power of 5 minus 6x by log a. Now what is the coefficient of x? It is minus 6. Finally we get minus 1 by 6 into a to the power of 5 minus 6x by log a plus c. This is the final answer. Next, 10th one. Integral secant of 4x minus 5 into tan of 5 minus 4x dx. When we look at this problem, here we have 4x minus 5 and here we have 5 minus 4x. But in the formula we have secant of ax plus b into tan of ax plus b into dx. It is equals to secant of ax plus b whole divided by a plus c. When the two angles are same, that is ax plus b and ax plus b, then only we substitute this formula. But here in this case we have 4x minus 5 and 5 minus 4x. Now using the trigonometry ratios, we can write secant theta is equals to secant of minus theta. So in the first step I write integral secant of, when we take minus out of it we get 4x minus, when we take minus we get 5 minus 4x. 5 minus 4x into tan of 5 minus 4x into dx. Now the two angles are same. We know secant of minus theta is equals to secant theta. Therefore in the next step we write secant of 5 minus 4x into tan of 5 minus 4x into dx. It is equals to, we substitute this formula here. It is secant of 5 minus 4x, and in the denominator, what is the coefficient of x? It is minus 4. We write it in the denominator plus c. This is the final answer. Next, 11th one. Integral cosecant of 2 minus 3x into cot of 2 minus 3x. Here the angles are same. Therefore, we substitute the direct formula. Formula is integral cosecant of ax plus b into cot of ax plus b into dx is equals to minus cosecant of ax plus b by a plus c. Now when we substitute it here, when we substitute the formula here, we get cosecant of 2 minus 3x, and in the minus cosecant of 2 minus 3x, in the denominator, what is the coefficient of x? It is minus 3. Write it in the denominator. Now this minus and this minus gets cancelled. Plus this is the final answer. Next, 12th one. Integral 3 to the power of minus 2x into e to the power of minus 2x dx. When we look at this problem, the powers are same. So in the first step, I write 3e whole to the power of minus 2x dx. Now this integration looks in the form of integral a power bx dx. Here 3e is compared with a. Now we know the formula for this. It is a to the power of bx by log a and coefficient of x is b. Write it in the denominator place. Now when we substitute it here, we get 3e whole to the power of minus 2x by log. In the place of a we have 3, log of 3e, and in the denominator we must write coefficient of x. It is minus 2. Finally we get minus 1 by 2 into 3e power minus 2x by log of 3e plus b. This is the final answer. Next one, integral to square root of 1 plus sin x dx. To solve this, we use trigonometric formulas. From the identities, in the place of 1, we can write sin square x plus cos square x is equals to 1. That is, sin square theta plus cos square theta is equals to 1. And for sin x, we can write 2 sin x by 2 into cos x by 2. Since here we have x by 2 angles, I write x by 2 here also. Now, integral square root of, in the place of 1, I substitute sin square x by 2 plus cos square x by 2 plus, and in the place of sin x, I substitute 2 sin x by 2 into cos x by 2 dx. Now, this is in the form of a square plus b square plus 2ab. We know the formula for this. It is a plus b whole square. When we substitute it, we get square root of sin x by 2 plus cos x by 2 whole square dx. This square root gets cancelled and we are left over with integral sin x by 2 plus cos x by 2 dx. Now, on separating integration for the each term, we get integral sin x by 2 plus integral cos x by 2 dx. We know the formula for integral sin x by 2. It is minus cos x by 2 and coefficient of x is 1 by 2 plus integral cos x by 2 is sin x by 2 by coefficient of x 1 by 2. Now we can rewrite this as 2 into minus cos x by 2 plus sin x by 2 plus, this is the final answer. I have got this 2 into the numerator place. Next, 14th one, integral 3x square minus 4 into x dx. In the first step, I multiply this x for this and we have 3x to the power 3 minus 4x and dx. Now, we separate integration for the each term. We have 3x cube dx minus integral 4x dx. Here 3 is constant. Take it out of the integration. 3 integral x cube dx minus, here 4 is constant. Take it out of the integration and we have 4 integral x dx. When we substitute the formula x to the power n, you know the formula, it is integral x to the power n dx is equals to x to the power n plus 1 by n plus 1. When we substitute it, we get 3 plus 1 by 3 plus 1 minus 4, and for integral x, in the place of n we have 1, x to the power of 1 plus 1 by 1 plus 1. Now on further simplification, we have x to the power of 4, 3 plus 1 4 minus 4 into x to the power of 2 by 2. Simplifying 2 ones are and 2 twos are. Finally we have 3 by 4 into x to the power of 4 minus 2 x square plus c. This is the final answer. Next one, 15th question. It is given as integral 1 minus 2x square into x. To solve this, we multiply x and we have x minus 2x cube into dx. I have multiplied this x for each term. Now, separating integration for the each term, we have integral x dx minus integral 2x cube dx. We know the formula, integral x power n dx, x power n plus 1 by n plus 1. When we substitute it here, we get x power 1 plus 1 by 1 plus 1 minus, here 2 is constant, we take it out of the integration, x cube dx. We can write this as x square by 2 minus 2 integral for x cube. When we substitute the formula, we get 3 plus 1, x power 3 plus 1 by 3 plus 1. And on simplifying, we get x square by 2 minus 2 by 3 plus 1, 4 x to the power of 4. On simplification, finally we get x square minus x power 4 by 2 plus c. This is the final answer. Next, 16th one. Integral 2x into sine of x square plus 1 dx. There is no direct formula to solve this. So, we go for substitution method. In substitution method, let us assume x square plus 1 is equals to t. Let this value be t. Now, on differentiating with respect to x on both the sides, d by dx of x square plus 1 is equals to d by dx of t. On differentiating with respect to x, 2x plus 0 is equals to dt by dx. From here, I can write dx is equals to dt by 2x. Now, when we substitute it here, integral sine of, in the place of x square plus 1, I substitute t, and in the place of dx, I am left over with dt by 2x, and I have 2x. 2x gets cancelled. I have written this 2x here, this 2x get cancelled, and we have left over with integral sine t dt. Now we are integrating sine function with respect to t. We know the formula for integral sine x dx. It is equals to minus cos x. When we substitute it here, we get minus cos t. But the value of t is x square plus 1. When we substitute it, we get minus cos of value of t, x square plus 1 plus c. This is the final answer. Next, 17th one. It is given as integral e to the power of log x by x dx. There is no direct formula for this, so we go for substitution method. In this, let us assume log x is equals to t. Now, on differentiating with respect to x on both the sides, d by dx of log x is 1 by x is equals to dt by dx. Now we can write dx is equals to dt by x. When we substitute it here, we get e to the power of log x value is t by x into, in the place of dx, we substitute x into dt. X into dt. Now this x and x gets cancelled, and integral e power t dt. It is equals to e power t. Integral e power x dx, e power x, and integral e power t dt, e power t. Now what is the value of t? It is log x, e to the power of log x plus c. Next, 18th one. Integral 8 power log x by x dx. To simplify this, let us assume log x is equals to t. On differentiating with respect to x on both the sides, we get d by dx of log x is 1 by x and for t dt by dx. We can write dx as this x goes here and x into dt. Now when we substitute, we get 8 to the power of t by x into, in the place of dx, x into dt. This x gets cancelled and we have integral 8 power t dt. Integral a power x dx. We know the formula for integral a power x dx. When we substitute it here, 8 power x by log 8, x power t. Now what is the value of t? It is log x. It is equals to 8 to the power of log x by log of 8 plus, this is the final answer. Next, 19th one, integral log x whole square by x dx. To solve this, let us assume log x is equals to t. On differentiating with respect to x on both the sides, we get 1 by x is equals to dt by dx. We can write dx as x into dt. When we substitute it here, we get, in the place of log, I substitute t square by x into, in the place of dx, we substitute x into dt, x gets cancelled and we are left over with integral t square dt. When we substitute integral x power n dx formula, it becomes x power n plus 1 by n plus 1, that is t power 2 plus 1 by 2 plus 1, t power 3 by 3. Finally, we substitute the value of t, it is log x whole to the power of 3 by 3 plus, this is the final. Next, 20 question. It is given as integral 1 plus log x whole to the power of n by x dx. To solve this, let us assume 1 plus log x is equals to t. On differentiating with respect to x on both the sides, d by dx of 1, 0 plus d by dx of log x, 1 by x is equals to dt by dx. Now, in the place of dx, we can write x into dt. When we substitute it here, we get integral t power n by x into x dt. In the place of dx, I substituted x dt. This x gets cancelled and we are left over with integral t power n dt. Now, it is in the form of integral x power n dx. So, we substitute the formula n plus 1 by n plus 1. What is the value of t? 1 plus log x whole to the power of n plus 1 by n plus 1 plus 3. This is the final answer. Next, 21st one. Integral 3x square by 1 plus x power 6 dx. In this, the first step, let me write this as 1 plus this x power 6 I am writing as x cube whole square dx. Now, let us assume x cube is equals to t. On differentiating with respect to x on both the sides, we get 3x square is equals to dt by dx. Now, in the place of dx, we can write 1 by 3x square into dt. When we substitute it here, we get integral 3x square by 1 plus, in the place of x cube, we substitute t. It becomes t square. And in the place of dx, we substitute 1 by 3x square dt. Now, 3x square gets cancelled and we are left over with integral 1 by 1 plus t square dt. This is in the form of integral 1 by 1 plus x square dx. It is equals to tan inverse of x plus c. When we substitute the formula, we get tan inverse of t. What is the value of t? Tan inverse of t value is x cube plus c. This is the final answer. Next, 22nd question. Integral e power tan inverse x by 1 plus x square dx. To solve this, let us assume tan inverse x is equals to t. On differentiating with respect to x on both the sides, d by dx of tan inverse x is 1 by 1 plus x square is equals to dt by dx. Now, integral e to the power of tan inverse x. In the place of tan inverse x, I substitute t, and here in this place that is dx by 1 plus x square is equals to dt. In this place I substitute dt. Now this is in the form of integral e power x into dx is equals to e power t. What is the value of t? E power tan inverse x plus c. This is the final answer. Next, 23rd one. Integral 1 by 1 plus 2x plus 1 whole square dx. We have direct formula for this. This is in the form of integral 1 by 1 plus ax plus b whole square dx. It is equals to tan inverse of ax plus b by, what is the coefficient of x? It is a. We write it in the denominator plus c. When we substitute it, here we get tan inverse of 2x plus 1 whole divided by 2 plus, this is the final answer. Next one, 24th question. It is given as integral sine of tan inverse x by 1 plus x square dx. To solve this, let us assume tan inverse x is equals to t. On differentiating with respect to x on both the sides, d by dx of tan inverse x is 1 by 1 plus x square, and for t, dt by dx. Now, in the place of dx by 1 plus x square, we can substitute dt. Now, integral sine inverse of, in the place of, sine of tan inverse x value is t, and in the place of dx by 1 plus x square, we substitute dt. Integral sin t dt minus cos t minus cos of, what is the value of t? Tan inverse x plus c. This is the final answer. Next, 25th one. Integral sine of log x by x dx. To solve this, let us assume log x is equals to t. On differentiating with respect to x on both the sides, d by dx of log x is 1 by x, and for dt and for t, dt by dx. dx by x is equals to dt. So now integral sine of, in the place of log x we substitute t, and in the place of dx by x we substitute dt. Integral sin t dt minus cos t minus cos of, what is the value of t? It is log x plus c. This is the final answer. Next, 26th one. Integral cos of log x by x dx. To solve this, let us assume log x is equals to t. This is similar to 25th one. When we differentiate it with respect to x, we get 1 by x is equals to dt by dx. dx by x is equals to dt. Here, integral cos of, in the place of log x I substituted t, dx by x. Integral cos t, in the place of dx by x I am writing dt. We know the formula for integral cos t dt. That is integral cos x dx. It is sin t. What is the value of t? Sin of log x plus c. This is the final answer. Next, 27th one. It is given as integral sin inverse x by square root of 1 minus x square dx. Now, let us assume sin inverse x is equals to t. Now, applying differentiation on both the sides. Differentiation on both the sides with respect to x. D by dx of sin inverse x is 1 by square root of 1 minus x square. It is equals to dt by dx. In the place of dx by square root of 1 minus x square, we can substitute dt. So now, integral in the place of sin inverse x, I substitute t. Dx by square root of 1 minus x square dt. Integral t dt. When we substitute the formula, t power 1 plus 1 by 1 plus 1, it is equals to t square by 2. What is the value of t? It is sin inverse x whole square by 2 plus c. Next, 28th one. Integral sin inverse x whole square by square root of 1 minus x square dx. To solve this, let us assume sin inverse x is equals to t. The same assumption. On differentiating both sides, we get dx by square root of 1 minus x square is equals to dt. When we substitute it here, we get, in the place of sin inverse x, I substituted t square, and dx by square root of 1 minus x square, it becomes dt. For integral t square dt, it is similar to integral x power n dx. That is t power 2 plus 1 by 2 plus 1. It is equals to t cube by 3. It is equals to, now substituting the value of t, that is sin inverse x whole cube by 3 plus c. This is the final answer. Next, 29th one. It is given as integral cos x by 1 plus sin x whole square dx. To solve this, let us assume sin x is equals to t. On differentiating with respect to x on both the sides, d by dx of sin x is cos x, it is equals to dt by dx. Now in the place of cos x into dx, we substitute dt. Integral 1 by, in the place of cos x dx, we substitute dt, and in the denominator 1 plus t square. Sin x value is t. This is in the form of integral 1 by 1 plus x square dx. We have the direct formula tan inverse of x, that is tan inverse of t. It is equals to tan inverse of, what is the value of t? It is sin x plus c. Next, 30. Integral 1 by 1 plus sin 2x dx. To solve this, we use trigonometric formulas. 1 by, in the place of 1, I use sin square theta plus cos square theta identity. Let me write sin square x plus cos square x. In the place of 1, I substituted this, and for sin 2x, we have 2 sin x into cos x formula dx. Now in the next step, we take cos square x as common. When we take cos square x as common, we are left over with sin square x by cos square x plus 1 plus 2 into sin x into cos x by cos square x dx. Now integral 1 by cos square x, it can be written as secant square x, and the denominator sin square x by cos square x tan square x plus 1 plus 2 into 1 cos, and cos gets cancelled, and we have sin x by cos x. It is tan x dx. Now let us assume tan x is equals to t. On differentiating with respect to x on both the sides, d by dx of tan x is secant square x is equals to dt by dx. In the place of secant square x into dx, we will substitute dt. In this place, we substitute dt by, and the place of tan x, t square plus 1 plus 2t. Let me convey it here. Integral 1 by, now this can be written as, it is in the form of a square plus 2ab plus b square. So that t plus 1 whole square dt. Now this is in the form of integral 1 by ax plus b whole square dx. It is equals to minus 1 by ax plus b into a. When we substitute the formula, we get minus 1 by t plus 1. Here coefficient of t is 1. Now finally, what is the value of t? It is tan x. Tan x plus 1 plus c. This is the final answer.